Today we're going to be talking about the distance formula. Hopefully this is going to be a pretty quick and easy lesson for you. Essentially, I'm just going to be giving you a formula. I'm going to tell you how we came up with the distance formula, and then I'm going to give it to you. And then you just need to plug in numbers and simplify. Um, so make sure that you have your notes out. Make sure you're taking good notes so you can have them for later. So this is going to be lesson 7.5, the distance formula. So let's first talk about how we got the distance formula. It actually comes from the Pythagorean theorem. And so remember, the Pythagorean theorem has to do with a right triangle. And we're looking at, in this case, the hypotenuse. So we're looking at the distance between 2 points on the coordinate plane. The coordinate plane is that graph thing that we use. So when you're looking at those 2 points and you're figuring out the distance, remember you can create that right triangle from the distance. We did that a lot in our, or at least a couple of times, in our notes, in practice problems, and on your last quiz. So these are the steps to discovering the distance formula. Since you're at home, I'm not going to force you to do this, but if you're curious on how it comes about, you can go through and follow these steps. So you can pause the video and do that. Basically, this is going through and telling you how to use the Pythagorean theorem in order to find the distance between the 2 points. The distance formula is just a simplified formula of doing all of that. So let's go ahead and look at that formula now. So d means distance. So distance equals the square root. So remember, the last step of the Pythagorean theorem is square rooting it all. So that's why we have that square root. And then we're looking at the distance. So it's the change in x over the change in y. Change just means subtraction. So we're subtracting our two x's and we're subtracting our two y's. Remember, with the Pythagorean theorem, we always square those numbers. And so we're getting that squared. Let me pause real quick and show you what I mean by all this. All right, I drew a little graph for reference, so it's not perfect, but you get the idea. So if I'm trying to find the distance between those 2 points, I can draw my straight line there and then my 2 connecting lines there. So if I had a graph available, I could go ahead and do this, no problem, figure out what A and B are to figure out what C is. But if you don't have a graph or you don't want to draw it out, the distance formula is how you're going to figure that out. So we're saying we're taking x2 minus x1. So that 2 and the 1 come from our 2 different points. So we're just going to pick one as 0.2 and one as 0.1. Doesn't matter which way. So if we said that this is x1 down here, and we're going to tell this one that it is x2. And so we're taking those two x's and we're subtracting them. So if we look at this one, we're doing 0 minus -3. So 0 minus -3 is going to end up being a +3, which makes sense because that's how long this side is, side A. It's 1, 2, 3 in length. And it works out for our y too. So this one should be 4 when we subtract it. So we're going to take y2, which is 3. And then we're going to subtract y1, which is -1. And when we simplify that, we end up with 4, just like we predicted. So that's giving you side length A and side length B. So then you can go ahead and square them just like you would in the Pythagorean theorem. So if I square both of those numbers, I end up with 9, and I end up with, here we go, squared. I end up with 16. So I just squared those two numbers. Since I'm solving for my hypotenuse, if I was doing A, that's our A, squared plus B squared equals C squared, I would go ahead and add those two numbers together, which is what it's telling me to do right here. When I add those two numbers together, I end up with the number 25. And then if I were doing the Pythagorean theorem, I would have to square root it to get rid of that squared right there. So I would have to square root this side. And that's what the distance formula is telling us to do. So this is just a super simplified version, or super simplified version of what we're doing in the Pythagorean theorem in order to solve for 3c, which is our distance between those 2 points. So hopefully that makes a little bit of sense to you. I can explain it better if you are still confused. If you want to, you can just kind of follow the steps on solving this and you should be good. So this is your distance formula and that is why it all works. So let's go ahead and clear that out and move on to some practice problems. So like I said, I'm not going to be giving you a graph for these problems because I'm expecting you to use this distance formula. So this is what a problem is going to look like. I'm just going to give you 2 different points and you're going to use those 2 points to find the distance. So we're going to go ahead and substitute these numbers into our problem. So when I'm looking at this, like I said before, I need to figure out what's 0.1 and what's 0.2. It doesn't matter which one's which. So we'll just call this one 0.1 and this one 0.2. Above each of these, I'm going to say what variable they represent, just so I don't get confused, because it's really, really easy to mix these up. So remember, our point is all the time written as x, comma, y. Now that I have all that information out of the way, I can use my distance formula. So I'm going to plug in my numbers. So distance equals the square root of x2. So we're at the second point, looking at the x. x2 is -4. So -4 minus x1. So first point, x is the number 1. We're going to keep the squared and the plus and move on to the second part, which is y2 minus y1. So second point, y is going to be -2 minus y1. So first point, y gives me the number 5. And then I keep my squared on that as well. Now I just have to simplify. So I want to figure out the distance between those 2 points, or the change of those 2 points. Or if you just want to keep it as simple as following the PEMDAS method, you can. You do parentheses first. So we're going to simplify those 2 parentheses. So we're going to be taking -4 minus 1. I'm going to KCO that, which means I'm keeping this first number, changing the subtraction to be addition, and then doing the opposite of the second number. So since it was a positive 1, it's now a -1. When I take -4 plus -1, I'm going to end up with the number -5. Keep the squared and the addition, and then we're going to figure out the second one. I see subtraction, KCO, and it becomes -2 plus -5, which is going to give me the number -7, and keep the squared. Following PEMDAS, we did the parentheses. Now it's time for exponents. So we're going to square both of these numbers. So we'll go green. We're finding the distance still, and we're going to square it. So -5 squared, or -5 times -5, is going to be a positive 25, because a negative times a negative is a positive. So if you end up with a negative number there, it's going to be positive. If you end up with a positive number, it's still going to be positive. So you should never have any negative numbers after you get done with squaring. So just keep that in mind. We're going to be doing the same thing to that number. We're taking -7 times -7, or -7 squared, in order to get positive 49. Now I can't do the square root yet. I'm going to have to finish up my addition in here. So when I do that, I am looking at 25 plus 49, which is going to give me the number 74. that's a 7. And now we're down to our last step. We're going to square root the number. This is going to be a lot easier if you do have a calculator on you. So you do have a calculator on your Chromebook, so make sure that you are using that. I'm going to use the calculator that's on my phone. So we are looking at the square root of 74. We're going to approximate it to the nearest tenth. So it is 8.6. And so the distance between those 2 points that I gave you is 8.6 units. I'm going to run through this one just a little bit quicker. So let's go ahead. If you want to pause the video and try that problem, go for it. And I'll explain every step of the way for you once you're done. So just like before, we're going to make sure that we have our labels. So we're going to call this one 0.1 and this one 0.2. We're going to make sure that we say that that's X, Y, X, Y. That for me never changes. So our first step is to substitute. So we're going to be substituting our numbers into our original equation. So I'm looking for x2 minus x1. x2 is going to be -5. And then minus x1, which is -2. Keep the squared and the plus. And then we're moving on to the second part, which is y2 minus y1. y2 is the number 1 minus y1, which is 3. Keep the squared. Now we're moving on to the second part, where we are going to simplify our parentheses. So that first parenthesis, I see -5 minus -2. Since I have a double negative there, I'm going to KCO it, keep, change, opposite. So I'm actually going to be looking at -5 plus 2, which gives me a -3. Keep the squared, plus 1 minus 3 is -2. Keep the squared. Following that order of operations, I'm going to square those two parentheses. So I'm going to end up with -3 times -3 is 9, plus -2 times -2 is going to give me 4. Now I'm going to add those two numbers together. When I add the two numbers, I end up with 13, which is not going to simplify easily. So we're going to go in and we are going to use our calculator to figure out what the square root of 13 is. So square root of 13 is going to give me 3.6. And so that's going to be my answer. Now you got some practice problems to work on your own. So go ahead and try these two problems using the distance formula. Feel free to rewind the video and watch me explaining those problems again. Once you're done, go ahead and check your answers against mine. So pause the video now. And these are your two answers for the practice problems. So for practice problem 1, you should have gotten 6.4. And for practice problem 2, you should have gotten 9.2. If you have any questions over these practice problems, please send me an email. We'll talk about it and figure it out together. The only thing that you have left to do now is your homework. So it's going to be a bunch of problems just like this one. It's going to be on page 322 in your textbook, and you're going to do numbers 11 through 17.